This is the video for equation basics. Let's talk a little bit about where equations even came from. So first of all, remember fact families back a long time ago when we learned fact families using addition and subtraction, multiplication, and division. They would use the same numbers to kind of go through and use the different operations, like 2 plus 3 is 5 and 3 plus 2 is also 5. 5 minus 2 is 3. 5 minus 3 is also 2. And same thing for multiplication and division. So we're in 8th grade, we used the dot and most of the time parentheses to represent multiplication. We also use this slash symbol or a fraction symbol to represent division, okay? We're kind of going away from the symbols that look like the X and the division sign like that. We move to different symbols. So let's use fact family knowledge to solve these basic equations in our head. So 7 plus what equals 10? We know that if we were using fact families, 10 minus the same number is going to give us 7. And I'm sure you can probably do this in your head. The answer is 3. And the same thing for multiplication and division. 6 times what number is 24? It's going to be the same thing as 24 divided by 6. The answer is 4. So we move from using a blank like this or a question mark like you might have seen before or boxes that you fill in to something that's called a variable. Now this variable usually looks like a letter. Most of the time we use X, but we could use any letter that we want to represent a missing number. And that's what a variable is. It is a missing number. Usually a mystery number, something that we don't know exactly just yet, because we are going to be solving for the variable. So some words that we use are solve when we figure out what the missing number is. We solve equations. Equations are things that include a variable, kind of like this. We could say that some number plus 4, we don't know what that mystery number is, could equal 3 times a variable. So this is an example of an equation that we could solve for the missing variable. We could solve for X. We could probably try to do this in our head to see what number adds to 4 would also get us the same thing as 3 times some number. But instead of having to try to just guess and check in our head, we use this thing called the inverse property, which tells us to start doing the opposite. When we are able to do the opposite of whatever operation we're doing, we are going to be able to figure out our variable. So let's take this first little equation as an example. 7 plus x equals 10. Now this 7 is a positive number here. If I were to do the opposite of whatever a positive number is to both sides of my equation, here's one side and here's the other, I would have to subtract 7 from both sides. And of course, we know that 7 minus 7 gives us 0, which means that all we have left on this side of the equation is a plus x. We don't have to write the plus because we know that that's a positive number. And over here, 10 minus 7 is 3. If you could have done this in your head, that's great. However, we're going to need to start using the inverse property to show our steps in solving equations. Let's move on to a subtraction problem. So x minus 8 equals 2. If I were working to find this missing number, I'm going to do the subtraction to make it use the inverse property to move it to the other side. Let's add 8 to both sides. And the reason I add is because this is the inverse property, but if you really want to think about it in a different way, a negative 8, which this is a minus 8, but we're gonna consider this a negative 8, added to a positive 8, makes that go away too. It kind of cancels itself out or equals 0, which is why we do that. We do the inverse property so that stuff can move to the other side of the equation. Now we have 2 plus 8, which is 10. The missing number was 10. Again, if you could do that in your head, that's great, but the inverse property is going to be used to help us write down our steps to solve the equation. Let's move on to some addition and multiplication and division. So we have two problems here where we have a division problem and a multiplication problem. Now, of course, if you ever have to use your calculator for some simple addition and subtraction, multiplication, division, that is totally fine. All right, so let's try to see this. Remember that 5 next to the x tells us that it is a multiplication problem. And the opposite of multiplication, the inverse of it, would be division. So if I divide this side by 5 and this side of the equation by 5, that would be doing the inverse operation. 5 divided by 5 actually equals 1. And we do not actually write 1x like that. We just write x, because technically there is going to be an invisible 1 sitting right there. Anytime you see an x alone, kind of like here, we see 1x, which is that. Okay, that is 1x. We see it. We just don't have to write the 1 because we see it. 30 divided by 5 is 6, but if you do not know how to do that, you press 30, divide by 6, or divide by 5, and you get the answer of 6. The next one is a division problem. I can tell it is a division because of this division symbol or fraction symbol right here, which is interesting because our calculator does the exact same thing. It turns it into a fraction form because a fraction is basically just division. All right, so if we are dividing and we're going to use the inverse, the opposite of division, we're going to have to use multiplication to get our number away from the variable to the other side of the equation. So I'm going to multiply by 2, and the reason I use parentheses is to represent multiplication. When I divide or multiply this whole fraction or this part of the equation, when I times it by 2, the division makes it go away. It's technically like if we were writing 2 divided by 2. We know that that equals 1, just like we did here, okay? So that equals x. X equals, and 3 times 2 is 6, pretty simple. All right, so let's move on to this new thing called terms that are alike. Terms like, wow, okay, I meant to say like terms, my bad guys. So what are the terms that are alike? What are like terms? They're terms that look the same. So see this 5x up here? If it was a like term to anything else, it'd look like this. Anything that had a number in front of the x, those are like terms. It could even be 3, 4, or 7, goodness gracious, or 4. These are also its own set of like terms. However, these terms are not the same as these terms. They are not alike. You might notice that these all have an x, a variable attached to the coefficient. These numbers are just constant. Okay, we can use like terms down in some equations below to help us solve equations. For instance, if we had 4x plus 3x and we said they equal 12, well, that's just like writing 4x's and 3x's. If I wrote 4x's and 3x's, I would be writing, and you don't have to write this part, I would be writing full x plus x plus x plus x plus x plus x plus x, because that is 4x's and 3x's. Together, that makes 7x's. These two terms right here were alike. So before I start using the inverse property, I'm going to go ahead and put those together to make it simpler on my own brain. So I now have 7 divided by 12. So now that I have just a one-step equation, just like I had up here, I know that this is multiplication. I use division, which is the inverse property, to solve for x. I now have 12 over 7. That is a fraction that does not reduce. So that is our answer. We leave it in fraction form. We do not reduce it. All right, so let's try another one with like terms. This one, the like terms are going to be these numbers. They are the constants. 10 minus 3. That's a normal subtraction problem that we just always can do, or are used to from math. 10 minus 3 is 7. So this turns into 7x. 7 plus x equals negative 4. This is normal. Okay, so this is back to those one-step equations. Let's take this 7 and subtract it from both sides. That way I can move it. The reason I subtract it is because I know 7 minus 7 is going to give us 0, which means I don't have to write anything down there anymore. I rewrite the x, and then I say negative 4 minus 7. And if you cannot do that in your head, you may use a calculator. The negative button is right here, negative 4, and then we say minus 7. We do not say negative 4 -7. We also do not type -4 minus -7. It will make a whole new problem. Okay, the answer for this is -11. If we really wanted to check, we could put this -11 back here. 7 plus -11 does give us -4. We could test it out. 7 plus -11, equals -4. So we were correct. Let's talk about solving how do we solve for a variable when it is multiplied by a fraction. It is this fancy word called the reciprocal. C-I-P-R-O-C-A-L. Reciprocal. It's a fancy word for saying keep, change, flip. Now, used to you did keep, change, flip in the younger years. However, we do not call it keep, change, flip anymore. We say let us do multiply by the reciprocal. So technically, if we had this fraction times the variable, we would have divided it. So we would have had 1/3 divided by 1/3 on this side. Instead of that, we're going to keep, change, flip, or multiply by the reciprocal, and we're going to multiply by 3/1, which is the whole flipped version. And 3/1 we know is just 3. 3 divided by 1, it's just 3. So technically, this right here cancels out. We have x equals 5 times 3, which is 15. Let's try another one. 3/4, x equals 6. I'm going to multiply both sides of my equation by the reciprocal. This cancels itself out. I am left with x equals, and I could do 6 times 4/3 in my calculator. I even have parentheses to do this. The trick to writing fractions like this in the calculator, you could just use the division sign. However, if you press Control divide, the little gray button, and then divide, it opens up a fraction bar for you, and you can type 4/3. And then enter. The answer is 8. It's the same thing as saying 6 times 4, which is 24, divided by 3 is 8. All right, what happens when the variable is multiplied by a negative? So like this. What happens when it looks like this? Remember when I told you we technically have that invisible 1 in front of the x always? It happens right there too. This is technically -1 times x. And so just like any multiplication problem, we're going to have to divide this number on both sides, -1, in order to make it go away back to just plain x. 12 divided by -1 equals a -12. You can check yourself in your calculator if you need to. Let's try another one with a little bit more negatives this time. So let's divide by -1 on both sides, and you get x equals a +3. 2 negatives divided by each other does equal a positive. When you come to numbers like this that are integers, multiplying, dividing, adding, subtracting that are negative and positive, please use your calculator to check. I know you like to do it in your head, but please use your calculator to check. And that is the end of this video.